Hello and welcome to section 3.6, a summary of curve sketching, and this is going to be a brief summary. We'll be doing more in class, but I just wanted to kind of give you an idea what you're going to be looking at. And so we're going to go through and we have to come up with all of these things. And you got to remember that there's going to be a lot of things that you're going to see here that you may miss if you were just to graph this on your calculator. So I'm going to go through and give you the first derivative because I've already done that. F prime of x equals 20x, and so you need to do these derivatives if you're not sure how I'm getting these. And so then I've got x squared minus 4x squared. Then the second derivative, if I continue on with that, would give me negative 20 times 3x squared plus 4 all over this thing, x squared minus 4, I believe, cubed, yes. Cubed. Alright, so there's the first derivative and the second derivative, and we'll use those along the way. We can find the x-intercepts by plugging in 0 for y and solving, and you will find out that you will get negative 3 and 0 and 3 and 0. Y-intercepts, if I put 0 in for x, you'll notice that I get 0 for x, and I believe 9 halves for y. And then vertical asymptotes is setting the bottom equal to 0, and when we do that, we find out that we have a vertical asymptote at x equals 2 and x equals negative 2. And then horizontal asymptote, remember that if we do the limit of this, then we would find out that we would get y equals 2. Since we have the numerator and the denominator have the same power, we have y equals 2. Any critical numbers is when we set the derivative equal to 0, and when we set the derivative equal to 0, we get x equals 0, so there's our critical number. And so then points of inflection is setting the first derivative equal to 0, and when I do that, I'm going to get imaginary numbers, so there are none of these. The domain of this function, well, it's going to be negative infinity to negative 2, because that's where an asymptote appears. And then from negative 2 to 0, and then, oh, actually, I take that back, not negative, then from negative 2 to 2, so then it's negative 2 to 2, and then from 2 to infinity, just basically where the asymptotes appear. Symmetry, well, if I put in a negative x into this function, I get the exact same thing back, so we're going to be symmetric about the y-axis. And then our test intervals are going to be everything, including our critical numbers and points of inflection. So it's going to be negative infinity to negative 2, negative 2 to 0, 0 to positive 2, and then 2 to infinity. So I set up this neat little table down here to kind of get what's going on. And you can see negative infinity to negative 2, negative 2 to 0. So you can see all my intervals, and I'm even putting in these points to find out what's happening at those particular points. So I don't test f of x. I never test f of x when we are in an interval. So I'm going to just cross out all of those guys. They're not going to tell me anything going on in the interval. F of x, remember, is a position. So we're going to find out what's happening at these particular points. That's the position we want to know. So now if I put in, say, like we pick a value that is, say, like negative 3, and we plug it into the first, and we're going to plug them into the first and second derivative. And let me see if I can grab these guys and take them with me, bring them down a little closer to where we're working. And so if I do that, if I'm looking at my first derivative and I plug in negative 3, I'm just worried about the sign. I don't care about the numbers. So negative 3 will give me a negative on top. Negative 3 gives me a positive on the bottom. So I'm going to get a negative out of that. If I put in negative 3 into the second derivative, I get a negative on top and a positive on the bottom again. So I get a negative, and so this basically means that we are decreasing and concave down. And so that's important information for the graph. And so then if I put in negative 2 into the original function, you remember that that's where a vertical asymptote appeared, so the bottom becomes 0, which is undefined. So we have an undefined there. And these are just things you notice as you go through these. Same thing happens for the first derivative and the second derivative. And when it's undefined everywhere, you have a vertical asymptote, which we already knew. Oops. Vertical asymptote. So knowing that, that's kind of a good piece of information for our graph. And then if we go from -2 to 0, plugging in, say, like -1 into my function, let's see, I get a negative on top, and on the bottom, I still get a positive. So in this case, I'm going to get a negative. And then in the second derivative, I put in -1 on top. Let's see, -1 gives me a negative on top, and a -1 on the bottom here will give me a negative on the bottom, which means I get a positive. So I'm still decreasing, but this time I'm concave up in that area. So then at 0, it's kind of important, going back to my original function, putting in 0 into the function. Well, we already did that. We did that for our y-intercepts, putting 0 in for x, and that gave us 9/2. So 9/2, and then plugging in 0 into the first derivative gives me 0. And plugging 0 into the second derivative, let's see, will give me a negative, well, it ends up giving me a positive number in the whole scheme of things. Let's see, that becomes 0, so we get negative on top and a negative on the bottom, so it gives me a positive. And so when we're at 0, when our first derivative is 0, that should tell us that we have a horizontal tangent there. And since this is concave up, this would be a relative minimum. And so think about this. If we got a horizontal tangent, we got concave up, and so we've got a horizontal tangent there, so that's where we're talking about a minimum. So then we're going to test the interval between 0 and 2, so I'm going to plug 1 into this guy. I get a positive on top, positive on the bottom. When I put 1 into this one, I get a negative on top and a negative on the bottom, so that's another positive. So this time I'm increasing and concave up. And so then if I put in 2 into all of my values, again, you'll probably recognize that they would be undefined everywhere, because this is another vertical asymptote. And so vertical asymptote. And so then plugging in 2 into both of these, or plugging a value greater than 2, if I plug 3 in, I'm going to get a positive here, and plugging in 3 into this guy will give me a negative on top and a positive on the bottom. So it looks like I am increasing, and this time concave down. Alright, so then I could go ahead and sketch a graph of all of this using this information, and I've already done that. And so let me kind of move this out of the way so we can kind of look at both things at once, if I can. And so what I have done here, let's see, so for the first interval, we are decreasing and concave down. That would be right here. Oops, that would be this part right here. And then we had a vertical asymptote, so you can see that. And then I was decreasing and concave up, so there's decreasing and concave up. And then after that, we had a relative minimum at 9/2. And so you could go through knowing all of this information and sketch a graph, and that's really what we're trying to do. So now we have a different function, same idea, but this time I went through and gave you the table, and this is just to figure out the characteristics and then get a sketch of the graph. We need to still think about all of those things that we have, so for vertical asymptotes, horizontal asymptotes, all that fun stuff, just to make sure that we have a graph. So if I look at this, do I have any vertical asymptotes? Well, hopefully you can see that I would not have a vertical asymptote for this one. But horizontal asymptotes, if you remember our limits to infinity, we have the same power. So we do have a horizontal asymptote at y equals 1 and y equals -1. Because of the square root, we can do one positive version, one negative version. So we're going to get a horizontal asymptote. Those are our horizontal asymptotes. Maybe crossing the x-axis, or the x-intercept. If I put 0 in for y and solve, you'll find out that x is 0. So if y was 0, x was 0, so we're going to cross the x-axis at 0, 0. Things that are kind of important. If I was to put in a If I was to put in a negative x into this function, I will change the function so it's not symmetric about the y-axis. I think we'll end up finding out that it's symmetric about the origin. But we'll talk more about that in just a minute. And so anyway, so I'm going to go ahead and look at what I've got down here. Again, you can see I have an interval. I didn't evaluate it at that function. I have just evaluated the derivatives. So I have a positive and a negative, which means I'm increasing in concave up. Oops, this should be positive, positive. Sorry, I made a mistake. So this should be positive, positive. So we're increasing and concave up. And if we did the derivative, you could find that. In this case, if I went through and put in 0 into the function when I found my critical number, I got these values, which basically means that I have, since 0 is in the second derivative, that's a point of inflection. And then finally, if I do this, if I get positive, negative, I'm increasing, and in this case, concave down. So, knowing my horizontal asymptotes, knowing I have no vertical asymptotes, and knowing this pieces of information, I have a point inflection at 0, 0. Basically, I would end up with a graph that would look something like this. You can see that I have my horizontal asymptotes, I have my point of inflection, which is also my x and y intercepts, and you can see that the graph is increasing concave up to increasing concave down, and that's really all we're trying to do with these. Just come up with a sketch from the given information. So then finally we have something that looks like this, and we're going to have to go through and do everything. I'm just going to kind of list things out. I've already done the first derivative, and the first derivative is 1 over 1 plus sine x. And go ahead and check them yourself. Second derivative comes out to be cosine over 1 plus sine x squared. And then if I go ahead and I'm just going to do a period of 2 because this thing's going to cycle of 2 pi. It's just going to keep cycling through over and over and over again. And then so then if I want to go ahead and find my x-intercepts, remember I put 0 in for y and solve, well, that basically means that my x-intercept is going to be at pi over 2 and 0 because that's when cosine is 0. So we end up with pi over 2. My y-intercepts, on the other hand, y-intercept is going to be at, well, let's see, if I put 0 in for x's, I get 1 over 1, which basically means I have a 0 and a 1. So that's what I'm looking at for my y-intercepts. And then I can go ahead and find vertical asymptotes. Vertical asymptotes, remember, set the bottom equal to 0. And so basically I'm trying to find out where sine is equal to negative 1. And that would be at, let's see, vertical asymptotes. Vertical asymptotes, when sine is equal to negative 1, is going to be either at negative pi over 2 or at 3 pi over 2. And so then we don't have, let's see, horizontal asymptotes, we don't have any. There are none for those. And you can see that basically to curve sketch, I got to find everything I need to know. Critical numbers, when I set this thing equal to 0, set the first derivative equal to 0, you can see that I'm not going to have any. So critical numbers, there'll be none of those. Points of inflection, oops. Inflection, basically when I set this guy equal to 0, it's going to be cosine equals 0 at pi over 2. So there's a point of inflection. And then we have, so basically we have our test intervals that we're going to use. And in our test intervals, if I set up a table here, I need a 5x5 table. And so now I can take my table here, let's fill it in. Oh, come on, Seriously. Let's see if I can move this table over. It's not letting me move the table. So using all of this information, we can kind of fill in our table here. And so we're going to have an interval. We're going to start with negative pi over 2. That's what x is going to equal. Oops, let's try this again here. X is going to equal negative pi over 2. And then we're going to go from negative pi over 2 to pi over 2. And then we're going to go at pi over 2. And then we're going to go from pi over 2. Oops, I don't have enough. Pi over 2 to 3 pi over 2. And then we're going to end at x equals 3 pi over 2. And so then we have our f of x, f prime of x, f double prime of x, and then our conclusion. And so there we go. So now we have our table that we have set up, and so we can go ahead and figure out what's happening. Well, we already know that at negative pi over 2, we're undefined in all of these guys because it is a vertical asymptote. So we know that. And then from negative 3 pi over 2 to pi over 2, if we pick or from negative pi over 2 to pi over 2, if we pick a value, you could pick pi or something like that, and plugging in that value, remember we don't do anything at f of x, we get a negative here and a positive there, which means we are decreasing and concave up. And then if we check at pi over 2, we know that we're going to get 0 here, and then we're going to get negative 1/2 and 0, which means we have a point of inflection. And then if we were to test this interval, we don't worry about that at all. And we test this interval, and we could get something somewhere in there. We could use, actually that one would have been pi. The other one would have been something like probably 0 or something like that. Yeah, 0 would have been a good choice for this guy. Pi would be a good choice for the second one. And we get negative, negative. Sorry, I messed up. And we get decreasing and concave down. And then finally, if we test here at this one, again, we know that this is undefined because we chose that as it ended up being chosen as a vertical asymptote. So if we were to graph this function, we could go ahead and plot all of these things, looking at all of these values, and we could get a graph that would look something like this. And you can see there's my y-intercept, here's my up and down, and you can see that I have more than between 0 and 2 pi, but it's good to kind of see all of this stuff. And so that's what your graph would look like. And so we're going to talk more about this in class. If you have any questions, please come to class prepared to ask them, and we will talk more about this.